Transistor characteristics. Bipolar transistors are one of the main building blocks in electronic systems and are used in both analog and digital applications. The devices incorporate two p-n junctions and are also known as bipolar junction transistors, BJTs. It is common to refer to bipolar transistors simply as transistors, the term FET being used to identify the field effect transistor. Bipolar transistors get their name from the fact that current is carried by both polarities of charge carriers, that is, by electrons and by holes, unlike FETs, which are unipolar. Bipolar transistors generally have a higher gain than FETs and can often supply more current. However, they have a lower input resistance than FETs, are more complicated in operation and often consume more power. Transistor manufacturers prepare data sheets that detail the mechanical, thermal, and electrical characteristics of the parts they make. These data sheets are often bound into volumes called data manuals. Table 3.1 is a sample from a data manual. It shows the maximum ratings and some of the characteristics for 2N2222A transistors. Technicians usually try to replace a defective transistor with one having the same part number. This is considered an exact replacement even when the manufacturer is different. Sometimes it is impossible to find an exact replacement. Data, such as those shown in Table 3.1, are very useful in these cases. The technician will select a replacement with maximum ratings at least equal to the original part. The transistor's characteristics must also be examined and matched as closely as possible to the original. Comparing two transistors often shows that they are very similar. For example, the specifications of a 2N3904 transistor are strikingly similar to those for a 2N2222A transistor shown in Table 3.1. One difference, not shown in the table, is rise time, which is 25 nanoseconds for the 2N2222 and 35 nanoseconds for the 2N3904. The data manual's 2N2222 is a switching transistor, so it is faster. However, it is possible to substitute one device for the other in most applications. One way for a technician to learn something about a particular transistor is to use substitution guides. These guides are not totally accurate, but they do provide a good, general idea about the device of interest. Another good source of information is a parts catalog. Figure 3.2 is a sample of transistor listings from a parts catalog. These listings may even include some of the non-registered device numbers. Notice that quite a bit of information is listed in the catalog for each transistor number. For example, a 2N5179 transistor is seen to use a TO72K style, to be a silicon NPN type, to be used as an ultra-high frequency, UHF, amplifier, to dissipate 0.2 W, and so on. Parts catalogs are available for a small cost or often are free. It is a good idea to gather a collection of these catalogs and obtain new ones as they become available. When an exact replacement is not available, substitutions are often made. However, substitute devices must meet critical specifications so that product safety, functions, and reliability are not compromised. There are hundreds of transistor case styles. Most are registered with the Joint Electron Device Engineering Council. The JED website shows transistor cases, transistor outlines, from T01 to T0249. Figure 3.3 shows 3 examples. SOT means small outline transistor. Transistor data sheets often provide case dimensions and identify the emitter, base, and collector leads. In some cases, the part number cannot be found in any of the available guides or on the original transistor. It may be possible to use a general type of unit in these situations. For example, the 2N2222A, or the 2N3904, is a good, general-purpose replacement for small-signal silicon NPN BJTs. Likewise, the 2N2905A, or the 2N3906, is a general-purpose PNP replacement. General-purpose replacements should be avoided in these cases. VHF or UHF applications. High-power applications. High-voltage applications. Substitute transistors must be of the same material and the same polarity. Also, be sure that size and lead arrangements are compatible. They must be based on the same technology. Circuit voltages can be inspected to give some idea of the voltage ratings that the new transistor should have. The power ratings can be established by inspecting the circuit current levels and voltages. Of course, the physical characteristics should also be similar. Finally, knowing the function of the original unit is helpful in picking a substitute. Substitution guides and catalogs often list transistors as audio types, very high frequency, VHF, types, switching types, and in other descriptive ways. Analog. Analog. BJT, bipolar junction transistor. BJT, bipolar junction transistor. Characteristic. Characteristic. Charge carrier. Charge carrier. Data manual. Data manual. Data sheet. Data sheet. Digital. Digital. Electronic system. Electronic system. FET. Field effect transistor. FET. Field effect transistor. Gain. Gain. Input resistance. Input resistance. Operation. Operation. Polarity. Polarity. PN junction. PN junction. Rating. Rating. Saturation. Saturation. Specification. Specification. Switching transistor. Switching transistor. Technician. Technician. Question 1. What is the full name of BJTs? Question 2. Bipolar transistors carry current by which types of charge carriers? Question 3. Bipolar transistors generally have a higher gain than which type of transistors? Question 4. Transistor data sheets provide information about which characteristics of the transistors? Question 5. What is the primary difference between bipolar transistors and FETs? Question 6. What is the maximum collector-emitter voltage for a 2N2222A transistor? Question 7. What are substitution guides used for? Question 8. What is a good source of information about transistors? Question 9. What does the TO72K style represent in the transistor specifications? Question 10. What factors should be considered when selecting a substitute transistor?